This is a rigging lab day, and what we're working on is applying mirrored systems. So a couple key advantages to mirrored systems that we need to discuss. The primary advantage of mirrored systems is instead of relying on just a belay, what you are doing is duplicating a lower haul system. So you have one primary lower haul system, which would typically be your main line. Now instead of creating a belay line, we're going to create a secondary lower haul line. And both of those systems are going to continuously lower and continuously haul together. Here's the big advantage of that. You have a tensioned line almost the entire time throughout the operation as your secondary, if you would, which instead of it being a belay where you may potentially have slack in it at different times in the operation, it is immediately assuming load. So it, in theory, reduces all the possibility for fall factor or any shock values if you do lose some portion of the load. The other big advantage of it is it takes that load coefficient and it distributes it equally between two systems. So in this application that we're doing with the rigging lab today, we've basically got a 3-person load. We have 2 rescuers that we've hauled up to do mid-height packaging, and then we've got a victim. That load, now if you're using the 300-pound coefficients, you'd be looking at 900-pound loads. We're not truly there. Our rescue Randy's missing lower legs, so our load is a little bit lower than that, and both of our rescuers are less than 300 pounds. But we've rigged in dynos at key elements to go ahead and illustrate this point for the students as they progress through this. We're going to walk through this whole system piece by piece. Again, keep in mind some of this is for rigging lab applications, but it's a great learning tool to build at your station or at your training complex just to work through the possibilities with mirrored systems and what they're going to gain you. So here at this primary hub for one of the lower haul lines, we've got this dyno rigged in. We've got the 3-person load assumed right now, and if we zoom in on this dyno, you're going to see that the load that we're carrying right now is between 210 and 220 pounds. Now, for a 3-person load, that's a pretty awesome reduction in load that's being applied to this lower haul system. The other nice thing about mirrored systems is you immediately reduce the amount of hardware and components required for mechanical advantage. Because regardless of that load, we're not concerned, or it's not such a necessity that we have the ability to go to 5-to-1s or 6-to-1s or 9-to-1s. When you're limited on some personnel and resources and you're trying to reduce that, each haul system can typically be run with a 3-to-1 mechanical advantage regardless of that load, and you're going to very efficiently and effectively move it because they're both hauling together. Okay, so here at this primary hub, that's our dyno. We got the 210. We're using MPDs. MPDs are vital to these operations because as you have 2 independent teams working side by side to lower and haul together, it takes a lot of coordination. And one system may get ahead of the other, and you may need to balance it out and come back down a little bit. So having a very versatile piece of hardware up here that allows you to transition between lowers and hauls fluidly and quickly is a really, really important piece to doing mirrored systems efficiently. So coming out of here, we've rigged in a 3-to-1. We're just going to kind of walk the line and go through each element of the system. Coming off this hub, we're moving up here towards this primary haul team. We've got their 3-to-1 rigged in. You can see they've maximized a haul lane, giving themselves an effective range to operate this system. They have rigged in a double up here so that they have the ability to go bigger than 3 if they need to without changing much of their rigging, using Persix's or progress capture devices. We continue up this line here and we put in a change of direction right here. We also have a load cell here at this change of direction. This is one of the new CMC load cells. One of the really huge advantages of using the CMC Rescue Enforcers is that you can download a mobile app which allows you to remotely receive all the calculations that this device is doing throughout the operation. So if you've got this rigged on top side and your operational commander's on bottom side, you can really keep a close eye on exactly what your system is doing if you don't have a dedicated person up there watching this load cell. Here at this directional, we've got a good wide angle for this directional. We've got about 270 pounds of force on this connection point right here. They've created a load distributing anchor system back here as opposed to a load sharing anchor system. Each one of those anchors are similar but also mediocre at best. So they've rigged relatively low, put in a good system that's going to, for the most part, transmit load equally to each one of those anchors and equalize this force. Also allows this to kind of center itself since we're pulling at some odd angles, not just laterally but also vertically. You'll also notice that We have the two swivels integrated into this load cell. Really important piece when you're rigging hardware like this, so that you're not going to put any side load or three-way loading on any of your hardware components. So we're swiveled throughout this system. This line then redirects up to a change of direction up at the top of the building. The change of directions are simply for learning lab purposes here today, so that we can do quick transitions down here on the ground side with rescuers, with load, and with all of our transitions. We're going to walk over here to the other system now, and we're going to analyze what they've built over there, which is basically a mirror image of this system. So here we go to the other side. You can see on this side, again, we've duplicated a load distributing anchor system. You can see they're both kind of articulating in opposing directions because of the primary angles of pull. We have the MPD rigged on at this point, and this is the primary hub right here, as opposed to this being a redirect going somewhere else. So this is their primary haul lane. You can see that they've got an upward deflection, so they had to kind of bring that down and out so that they weren't trying to advance a haul system up towards that primary change of direction. So although this is the same system in mechanical advantage and application, it is a different system in exact rigging. So don't feel like, or don't get your brain in a box with tunnel vision and thinking that they've got to do exactly the same things. You don't have the same advantage, the same possibilities as far as lower haul capabilities, but you can put directionals and other rigging elements in depending on the environment. As we progress through this, you can see that they've elected to use a CMC CSR as a directional anchor component that gives them a moving directional crew. So they can change this angle, they can change this height, they can manipulate this as needed to put that directional anchor where they need to. And then back on the two anchors back there, they've used two anchors, put in a load distributing system back there as well. The CSR is self-minding, so it gives them good play, good load capacity, and good ability to manipulate this component as much as they need to. We're now going to work our way up towards our rescuers and our victim. We're going to talk about the rigging components up there.
Stop. Bring white up, just have them stay lower. Just make sure the back is staying vertical until Max can get the back. Alright, white team. All slow. Until Max is in the position. When Max in position, call slow. Stop. So bring them up together now. Have Matt get in the position. Okay. Blue team, all slow. All slow. Stop. Are you going to be able to get over there, Matt? Yeah, that's it. Back on. White team, hold slow. Stop. Go up on blue. Okay. Blue team, hold slow. Hold slow. Stop. How you doing, Ham? Can you go up a little more, Wendell? The unloading. You need some more? On blue?
Yeah, probably a little bit.
Okay. Blue team, hold slow.
Hold slow.
Stop.
That's good.
So we've added some other facets in here, just as learning tools. We've got a tagline assembled with a double by 8 going to the Stokes basket itself. We also have rigged in an Aztec to one end of the Stokes basket because in this application, they're performing litter scoops. So they're approaching this mid-height victim who's on a fixed line, meaning we can't bring that victim up or down. He's in a set position and we've got to get his load off of his system. Sometimes we've got to assume the victim and bring the victim up. The only way to do that is to run both of these mirrors directly, bring the basket up flat under the victim, and then literally take the victim up so that his load comes off of that primary system, unrig him, and bring him back down. In this application, they brought the basket in vertically. They had the Aztec rigged to the feet of the basket, and then they simply hauled up the feet of the basket, making sure that the high set or the head set on the Stokes was higher than the victim. As you bring the feet up, it just naturally assumes the load of the victim, brings him right into the basket. Then you can detach him from his primary line, secure him with mid-height packaging, and then when these two rescuers are ready to come down, down they come. On each rescuer, you basically have a master attachment point coming down beneath each of their primary lower haul lines. You have rigging plates rigged in, and then they've elected to use pick-off straps as their secondary attachment point so that they have some adjustability on rope. They can manipulate their position and orientation to the Stokes basket. There are some other devices that would give you more versatility there. Probably the ideal one being a CMC Aztec rigged in to that component so that they have the ability to go up and down with ease. Remember, with your pick-off straps on those attachments, once you set them and you've loaded them, it's very difficult to continue to change your position, especially in lowering yourself. So once you've hauled up, you're kind of set. You can continue to go up, but it's difficult to come back down. So think about your versatility, think about your pre-rigging when you get into that application. One last element that we haven't discussed yet is belays. When you do mirrored systems, you really got to contemplate the importance of your belay, the necessity of your belay, whether it's going to help you or hinder your operation. When you're doing two rescuers like this, you end up with a lot of rigging and a lot of elements coming over the edge and going to the load and to the rescuers. We encourage belay use. We're not fans or advocates of singular lines that don't have any redundancy in place. If you look at the system in entirety, because you have two mirrored systems, we have chosen not to use a belay in this application because each of the mirrored systems are assuming portions of the load and supporting one another. The one potential downfall of this application is if you did lose one of your lower haul systems, the other rescuer would pendulum underneath the other rescuer, and then you would have all three loads dependent upon one singular system without a belay line rigged in place. It's not as much a load concern for us as a possible critical failure. If we have any sharp edges, anything impacts that rope, there's just no secondary redundancy. So in the working world or a real rescue environment, a belay would probably be a component that you would definitely want to consider applying in this application, not just in a rigging lab. Remember also, because we are doing a 3-person load, having dedicated belays to each rescuer, or at least a singular belay coming down to the victim or split out into tails to the rescuers as well. A lot of versatile options there, okay? So just contemplate the belay, how you would work it into this, but remember the advantages of mirrored systems, immediate assumption of loads, no slack in either system, reduction on load capacity applied to each system, reduction on hardware per dedicated system, and limiting your mechanical advantage buildups. Makes your transitions quicker, makes your movements quicker, makes the whole system a little more versatile. That's mirrored systems in a nutshell.